Alright, today we're back again talking about quadrilaterals, and today we're going to just talk about how to compare them with one another and classify them, put them into groups a little bit more specifically. So on our first problem today, it wants us to describe at least two, this word right here is attributes. You're going to see this a lot when we talk about shapes. You've probably already heard me say it on the videos from 15.1 and 15.2. But when they talk about attributes, they just mean things that the shapes have. So the attributes are things that make that shape that shape. So straight sides can be an attribute. Having four sides can be an attribute. Having four points or vertexes can be an attribute. Anything that a shape has that can help us identify it is an attribute. So it wants us to pick some things out, basically, that all these shapes have that are the same, and then pick some things out that are different. So as I look at all these shapes, they are all quadrilateral, so I notice that right away they all have four sides. So that's one thing that they have in common, that they all have four sides. I also noticed that none of them are rectangles. We talked about how a square can be a rectangle, but its most specific name is a square, so none of them are perfect rectangles. If we're going to pick two attributes that are different, I could say some have right angles, some have those perfect corners, some don't have any right angles, so that's something I noticed right away. Some have sets of parallel sides, like here and here, and here and here, and some shapes have no sets of parallel sides, like this one. They would run into each other eventually. So attributes just simply mean, what does a shape have that makes it that shape? How do we describe that shape? This is something that you might want to pause and try to challenge yourself to do, to draw a quadrilateral that's different from all the quadrilaterals above, and then tell how it's different. We just said a minute ago when we were talking that none of those were rectangles, so that might be a quadrilateral that I draw down here because it's different than all of these above. You could also draw something completely different. Just a regular trapezoid would be fine, even though this one is a trapezoid because it has one set of parallel sides. But a regular trapezoid looks a little bit more like this with two slanted sides. There's a lot of different ways you could draw shapes. You could draw something concave, like that. You could draw something convex that only has those sharp angles. So whatever your brain can come up with, see if you can come up with something different than what I've got there. All right, on this next one here, we're looking at this group of shapes, and we just want to think, they're all quadrilaterals. How can we define the attributes of them? How can we tell what's the same and what's different and sort them into groups based on that? Well, one way is that we could pick out the parallelograms and put those in a group, and then all the ones that are not parallelograms can be in a group. Remember, to be a parallelogram, you have to have two sets, two of parallel sides. So that's one. This guy's got two sets. This guy looks like this guy. Yep, he's a parallelogram. And then all of these other ones, they're not parallelograms because they have at least one set of lines that would eventually cross and run into each other. So we could separate them as parallelograms and not parallelograms, just to keep it simple. So that's one way we could definitely sort these by their attributes, whether they have parallel lines or not. Another way we could think of this is if we think about shapes that have right angles, kind of like we talked about on the last page. I see that shape E here has some perfect corners, has some right angles. Looks like D also does, and then G. I don't see any others that have right angles, so those would be in a group for themselves, and then the others would be in a group that don't have right angles. So that's another way you can classify. You're starting to see there's lots of ways we could clump these shapes together, I'm sure. Okay, and then even one more way that we could do that is put the ones that are rhombuses into groups. Remember, in order to be a rhombus, you have to have only one set of parallel sides. They have to be in opposite sides. So this guy's a rhombus because he has one set of parallel sides. Looks like This guy's a rhombus, has one set of parallel sides, and that looks like it for rhombuses. Technically, you could classify this guy as a rhombus, but it is more than likely just going to be those two. And you notice that shape D here was in every single one of those groups we just created. Like I said, a lot of different things you can do. You could classify them into groups where you have convex shapes in one and concave. Remember those from a few lessons ago. Convex are ones that don't have any points that go inward. Concave have some points that kind of cave inward like we see right here. Okay. Down at the bottom, which of the shapes above can you cover with whole unit squares and not have any gaps or overlaps? So basically, which one of these or which ones of these could we cover perfectly? Which one of these or ones of these could we cover perfectly with unit squares to find the area? Well, if we tried to cover some of these with squares, we'd be able to get started nice and neat, but then we'd have these shapes like this that are not perfect squares. So in order for us to be able to use perfect squares, that shape itself has to have 4 right angles in it. 4 of those perfect corners. That helps us determine if a shape can be covered in unit squares or not. Even this shape right here does not have right angles, so the little boxes you create are not going to be perfect. You're going to get these kind of in the corner that are not perfect squares. So in order for us to find the area easily and cover them in unit squares, they have to have 4 right angles. Last thing we're going to do today, we're actually going to skip down to the bottom part today because the top would make us flip back to that page before a lot of times. So let's just keep it simple down here on the bottom. We're going to use this set of shapes and we're going to decide which ones fit each description. So which one or ones of these shapes is not a parallelogram? Remember, parallelograms have 2 sets of parallel sides. So this guy definitely has 2 sets of parallel sides. So he is a parallelogram. We would not include him here. It looks like B. If I kept extending those lines forever and ever and ever right here, they would eventually cross because that top's a little slanted. So B is not a parallelogram. It looks like also C, because if I kept extending that one and this one, they would cross. So it is not a parallelogram. D looks like it has 2 perfect sets that would never ever cross. E would cross, so it is not a parallelogram. F looks like it's pretty perfect on those sides. G looks like it's pretty perfect. Those would never cross, and those would never cross. So B, C, and E is not a parallelogram. Okay, the next one we're going to look at which one or ones of these is a quadrilateral, but not a parallelogram or a trapezoid. Remember, we just talked about a parallelogram has 2 sets of parallel sides. A trapezoid has 1 set of parallel sides. So if we're looking for a shape that doesn't have 2 sets of parallel sides and doesn't have 1 set of parallel sides, we're truly looking for a shape that has no sets of parallel sides. We just said that B, C, and E are the only ones that are not parallelograms. Well, E still has that 1 set of sides that are parallel, and B still has a set that are parallel. So C is the only one that is not a parallelogram or a trapezoid because it has no sets of parallel lines. Number 7 is a square and not a parallelogram. Remember, in order to be a square, you have to have 4 right angles, 4 sides of equal length, and you have to have 2 sets of parallel sides. I was blanking on which attributes I already told you guys. So you have to have 4 sides of equal length, 4 right angles, and 2 sets of parallel lines. So basically they're asking, hey, which one of these is a square and not a parallelogram? That would be this one, D. Now, technically, is this a parallelogram? About to blow your mind. Yeah, It is, but is a parallelogram the most specific name we can give that shape? No, we can name it a square. So that's why they're wording it like that. Hey, it's not a parallelogram. Yes, it is, but it's most specifically named a square. Remember how we talked about shapes can be lots of different names, and the best name to use is the most specific name. Okay. Now we're looking for one that is a rhombus, is not a rectangle. So remember, in order to be a rhombus, you have to have two sets of parallel lines. You have to have four sides of equal length. Okay, similar to a square, the only difference is they don't have right angles in them. A rectangle has to have right angles, it has to have opposite sides parallel, and it has to have two sets of sides that are the same length. So this guy is a rhombus. It looks like all four of his sides are the same length, and he has no right angles. Opposite sides are parallel, so he would definitely be included. Let's see if any others would be. B is not a rhombus because it does not have four sides equal length. Neither does C. D is a rhombus, but could D also be considered a rectangle? Yes, it could be. So we can't include that. E, nope, that's a trapezoid. It would definitely only has one set of parallel lines. F is a rhombus is not a rhombus, I'm sorry, because it doesn't have the four sides that are the same length. So we can't include that. It's also a rectangle, so we definitely can't include that. This guy looks like a rhombus. The reason he's not a rhombus is because this side is longer than these sides. So in order to be a rhombus, you have to have all sides equal length. This guy's just a parallelogram. He doesn't get a fancy name. Okay. Lastly, which one is a parallelogram and not a rhombus? Hey, guess what? We just talked about that. That would be shape D. The reason it's not a rhombus because all the sides are not the same length. So draw yourself some shapes or grab these shapes from the previous page over here and think about which ones would fall into those categories. You can use this set of shapes, freeze this right here if you need to, and you can actually practice with this set of questions right here, just telling the difference between all those different kinds of shapes.